Thank you.
Hi, so welcome to our session. This is what's new in C# 10. I'm Chris, and we have Fred with us as well.
Hello.
So I've been a Roslyn developer for roughly 3 years now, but I've been at Microsoft for over 10. You'll see me on GitHub as @Sienkiewicz, which is my email address at Microsoft as well. And you can also come and bug me on Twitter @Chis09. We're pretty active on Twitter, so feel free to come ask questions, come get involved in discussions.
And I'm Fred. I've been a Roslyn developer for about 5 years on various different parts. Compiler has been about 3.5, nearly 4 years at this point. I'm a member of the C# language design team, and you can find me on GitHub at 333fred, or you can find me on Discord at discord.gg/C#. Also 333fred there, usually, unless there's some kind of name meme going on at the moment. And I don't have a Twitter, so you can't find me there.
Okay, so what are we going to do? We're going to look at, mainly, we're going to jump into some C# 10 demos. It's pretty demo heavy. We'll just spend the most of the time in Visual Studio. But then we've also got a few slides at the end where we'll look at some of the ideas we're thinking about what's coming in C# 11 and beyond, and kind of where the language design is currently going. So with that, shall we jump into some demos, Fred?
I think that's the most interesting thing we could do.
I think slides are boring, right? I think that's enough slides. Yeah. So we have this program here, which you've probably seen before if you've seen any of the C# demos from the last couple of years. And it's really a C# 9 demo, right? It's showing off records. We have this record called a person, and we create this new person, and then we update some properties on them, and we show that records have equality built in and unique equals, and it's very exciting. And you run it, and you say, "Oh, there we go. Look, there's some people, there's some operators." So let's start with this and make some changes for C# 10. So the first thing I'm going to say is we've got this record. What actually is a record under the hood?
Yeah, so under the hood today, a record is a reference type. It's a class that has value type like semantics. And so what that means is that new person and those withs, those are each going to allocate a person. They're going to go off into the heap and make some memory somewhere.
Right, so this is a pretty groundbreaking feature, right? I can say, well, if it's going to be a class under the hood, I should be able to say that it's a class. So yeah. Ship it, right?
Yeah, I think we might want to go a little bit just beyond allowing you to specify class, though. So in C# 10, we're going to allow you to say record struct instead of class. And so what that does is now this person is a struct type. It is not a reference type. Yeah. And so that new and those widths, those are just struct copies. Those aren't actually allocating space on the heap.
That's cool. And so we're creating these things on the stack, and then we're mutating them, but they work exactly the same, right? I can just run this, and look, it all works, right? So really, we're just changing the underlying storage medium for the record to be a struct instead of a class. So that's pretty cool.
That's the idea.
But we made some other changes, not just for record structs, right? We've made some changes for structs in general.
Yeah. So this whole the wither, right? A with can actually. The compiler already knows how to duplicate structs. We do it all the time when we're calling methods and what have you. So what we actually did was we said, all right, well, why can't with apply to all your structs? And so now the only thing that starts failing in this is that equal, because there is no equal.
Yeah, it will catch up.
There it goes. Took a moment. So that structs don't have an equal operator by default, but everything else continues to work, including those with operators.
Right. So in C# 9, these would have had squiggles as well, right? Saying you can't do this on a struct. This is only for records, but now you can, right?
Yeah. And I mean, as I said, the compiler already knows how to do this. We do this all the time. And so it makes sense that you can use a with here as well.
Right. And this kind of, some of the themes we have in this version of C# is around kind of unifying these different ideas and types and concepts in the language, right? So we don't like having syntax, this special with syntax that only works with records. And so it's like, well, you know, a record really is just a kind of like, you can think about structs as being like a record anyway. So you should absolutely support the syntax on them rather than saying, oh, well, no, it only works over here or it doesn't work here. We just kind of unify everything together and make everything work nicely. So that's pretty nice. And then we have another kind of thing as well, which is a bit like a struct and a bit like a record, right?
Yeah, so that's anonymous types. And so if we go ahead and make this an anonymous type,
so we can now see that this is no longer a person. This is just an anonymous type with these two fields, first name and last name. And yet this is still working.
Yep. So anonymous types are to record classes as tuples are to record structs. And so, you know, if you think of a table where you have reference types and value types, and then you have like the default, which is either a class or a struct, then you have an anonymous set of values. And so for structs, that's tuples. For classes, that's anonymous types. And then you have named sets of values, which are either record structs for value types or record classes for reference types. And so we really took width, which was only in this one section of the table, and we colored in the whole thing except classes.
Right.
We would like to do that at some point in the future, but
not yet, but sort of on our radar. Yeah. So we did some other things for struct too, right? We didn't just do these withers. We've added some extra features. And one of the things you've never been able to do with structs is put a parameterless constructor on, right? And that's because we've always said, and this is kind of a philosophy thing in C#, that if we have a default person or we have a new person, these will always be the same object, right? Now, this is obviously not true for classes because default is going to be null and the new is going to run the constructor. But in struct land, we've always said, no, these two things are the same because the compiler sort of owns the constructor for person and will ensure that the constructor that gets generated is the same as default, right? It just says kind of zero everything out, give us the default values of this struct. But we're changing that, right?
Yeah. So C#10 is going to allow you to define parameterless struct constructors. And so this is a thing that people have asked for quite some time. I've certainly wanted myself. And so if you have some default values that you want to give, you no longer need to make a static create method that then calls a private constructor that takes both parameters or something like that, right? You can just call it with new.
Right, and this now means that these two instances are going to be different, right? They're not going to get the same thing because this is going to have empty strings in the first and last name, whereas this is going to have our filled-in values.
Exactly.
And so there's this has kind of always been allowed, right? You could do this with like crazy IAM and such, but we never allowed it in the language, and so we do now. And that has some implications, right, for things like array creation. In the same way, if you create an array of objects, you get them all null. Now, when you create the structs, you get them all default. We don't run that constructor in the same way.
Right.
So it kind of mirrors it. And it's kind of one of those things where, again, there's just this slight unification where it's like the language had different rules for these different kind of things. And now we're saying, no, you know, let's make these the same and make them a little simpler to understand the sort of concepts behind them.
And even going further beyond that, right? You know, in classes, we generate you a default constructor if you don't have any other constructors, and so we can do something similar with structs as well now.
Yeah. So what if we we couldn't before use any initializers in a struct, right? We had to have the parameters, and it was pretty pain. We couldn't really ever give structs default values, but now we can, right? So we can actually just say that these things get these default values, and now we don't actually need these at all. And the IDE is still happy, right? Because we're actually saying, well, there's a constructor here, but we've initialized these values, so the struct is good, right?
Right.
And in fact, we don't even need this constructor at all, right? Because the compiler is going to go in and just generate it for us sort of automatically. But we can now have these. We can just say, oh, it will go. Before this would be an error because it would say, oh, well, the constructor we're trying to generate is not, you know, you can't do that, right?
Right. And it's important to note that the rules for constructors here are very, very similar to classes, which means that if you define a constructor that takes two values, right, for example, or takes some number of values, you no longer have a default constructor. And the compiler isn't going to generate you a default constructor unless you ask it to. So with this code, with this example, that those P1 and P2 are the same. But if you then add an empty constructor, you will then be able to, then those two will be different again.
Yeah. So it's very much the same rules as classes and just now applied to structs. So pretty cool. Okay, so I think we've been using this file for a while. Perhaps we should try and enterprise it up a little, right? Most people don't just write 31 lines of C# in a single program file. So let's see some of the other things we've done in C# 10 that are more, actually like help you organize projects, make things big. So let's start by make our person be its own type. So there we go. It's very nice. The IDE can help me out. And if we're going to be enterprising, we need a namespace, right? We can't just have these things floating around. So let's give it a nice enterprising namespace like model. But now I've got all this white space, right?
Yeah.
We don't like white space.
And it turns out that literally 99% of C# files, 99.99, I believe, is the number that we came up with after we looked through GitHub at basically every C# file that we could index, and just searched and saw that literally 99.99% of files have a namespace and some number of types in them. Just one namespace, not anything nested, not anything like complicated. Just a namespace and a bunch of types in it. And so we wanted to simplify this, again, literal 0.001 percentile case, and add file scoped namespaces is the name of the feature.
So we can just get the ID to do this for us, and then no white space. So what's going on here?
So basically, what you can put at the top of a file or anywhere that you could put a namespace previously, and you can just say namespace semicolon, and you can have one of these in a file. And what it means is the rest of the file is treated as if it is surrounded by braces. So it's as if you had written the exact same code before, including if you put usings inside, usings outside. Those mean the same things as they did in the actual hierarchical syntax, but it gets rid of 4 spaces across the front of just about every C# line in existence.
Right, and so yeah, most files are going to just have that bit of extra white spaces. We don't need that ceremony. What happens if I try and put a namespace inside here? Can we nest them? Right.
So one of the things that we thought about this was we don't know what this means. But there were 2 reasonable camps here. One person can say, oh, Model 2 is in a nested namespace inside Model 1. And another reasonable camp is Model 2 is a sibling namespace to Model 1. And so we look at that and we go, don't know what you want. We don't know which thing you meant. And again, 0.001% of files encounter this problem.
Exactly.
It's okay to continue using the existing.
So just go use the existing, exactly. Okay, so that's good. We can shift our code across to the left a little. We can make our horizontal bit. What about our vertical space? We're trying to get rid of things. Like in this file, I've only got system IO, but in a regular file, I'm likely to have like using system, right? Or what would I do if I had some different versions of C#? I'd have like if we're C#2, we're probably going to be using generics, right?
Yeah.
Or if we were in C#, probably going to be using link. If we're in C#5, we're probably going to be using threading.tasks. So this is all goodness, but I'm already getting this big block of stuff up here. So is there anything I can do about that?
Yeah, and as you were mentioning, we kind of view these usings as, all right, I need to pay these in order to use the version of the language that I'm on, because that's where the types from that version of the language were defined. So what we did is in C#10, we said, all right, we're going to allow global using statements. So in generally some dedicated file, what you're going to be able to do is you're just going to put the word global in front of your using statements.
Look at
Type
that.
global here, and now all of those, it's as if the compiler is taking any using statement that is prefixed with global, and it's just pasting it at the front of every file in your compilation, every file in the project.
So when we go back to person here, I can now say, these are no longer needed. Look at that.
And
So
the file still works.
Yeah, and there's no errors, everything's working. So these get pasted into that file. What's the sort of, how far do they go? Like, what's the boundary of where these go? Which files do these go into?
Yeah, so these apply in every C# file in your project. So this particular project has 4 C# files, I think, in it, and so it applies to every single one of them.
Nice. And we had that model thing as well, so I should just go and say, let's go use that as well. So it's not just system namespaces, right? I can put anything I want in here. And we've also got this. We notice we're using a static here as well, so I can just write line anywhere. In fact, and if we go back to our program again, I can say, oh well, these are no longer needed now. So pretty cool.
Yeah, and you can put anything in a global using that you can in a regular using today. So if you wanted to have an alias, for example, you could do an alias if you have some dictionary type that you're using everywhere, for example.
So, I've got some dictionary of some horrible, how else do I actually type dictionary? Some horrible type here. And now I can actually, in here, I can now go and actually just reference that type, right? So and the IDE will correctly say, oh, this thing is a dictionary. And we used to do this before, right? You could put this at the top of the file, but then anything calling into that file, your API, you wouldn't get that alias, right? You'd get the dictionary. And so if you wanted to use that alias again, you'd have to copy paste that alias across the files. And it kind of got a little messy. So now you can just say, no, anywhere in this project that you see my type, it's going to be one of these dictionaries. So that's pretty neat.
And while we're doing it in a dedicated file right here, you can actually do it in your project file and configure it across multiple different projects, for example.
Oh, so let's go do that, shall we? Let's go. So we have this new property called implicit usings. And if we turn these on and go back to our usings here, in fact, it's going to go and pull out a bunch of them for us automatically. And so how does it do? Like, how does it pick which usings it needs to know and which usings are we going to get from this?
Yeah, so that depends on the project. On the project type. Each different type of project has its own set of usings. Like, for example, ASP.NET has a customized set of usings that includes some ASP.NET things, and Console app has a much simpler set of usings that just include the very basics that most programs are going to need.
That's great. And so I can now just say, you're the compiler, you probably know what I'm using based on my language version and the thing I'm building. Just go put those usings in my project, right? I don't need to put them in every file. I don't need a dedicated file. I can just go do it. But you were using that model thing, right? And perhaps we're saying, oh, well, maybe we want to use this too, right? We want to actually control the set of usings we get with implicit usings. And we can do that too from the project file. So you can actually just go in and add a using here. And then this essentially does the same thing. So this just says, as well as the implicit usings, use this fancy model thing we've declared. And again, when we go back to our usings, we can now see that helps to say project file. Okay, well, model is no longer needed because we're actually including it as part of our project file instead. So everything will still build and work correctly.
Yeah, and those directives allow you to really customize the list of usings. So if you wanted to remove things, you can absolutely say, no, this doesn't make sense for mine. You can do that.
Yeah, so you've got control, and it's not like this gives you the default set, but you can always go and change these things as you need to, right?
Exactly.
Cool. Okay. Let's go look at some other things, shall we? So that's usings. We've done a lot of. So we've seen, our unification of our concepts. We've seen how we can make our files list verbose. What else did we do? We did some work on lambdas, right?
Yeah. So one of the things that newcomers to the language often ask is, all right, so I have this lambda, And it's obviously a function that takes a string and returns an integer, because what else could it possibly be doing? Why can't I just type var again? Why does the compiler not figure out a type?
Well, maybe we should just do that.
Yeah, maybe we should just do that. And so with C#10, we just do that. So if your lambda can be put inside of a func or an action, we'll just go ahead and do that. And if it can't be put inside of a func or an action, we'll make a custom anonymous delegate type, very similar to like an anonymous type in general, that will allow us to represent all of your lambdas and actually figure out and flow a type for that lambda through the type system.
Right, and so here the compiler's figured out that this thing returns an int and takes a string. But then if I don't have this, then we're going to run into trouble, right? The compiler can't figure out what this thing is, because how would it know, right? We've lost, there's not enough information there.
Right. Yeah, I mean, some languages can actually figure that out, but C# is not a language that is built.
Yeah, I mean, we could sort of go into the parse and grok that it's a string and try and push that back, right? But then we get into like body analysis, and we're just like, no, we don't want to do that. We don't think we should be in the business of doing that. Like, just tell us what you want, right?
Yeah.
Cool.
Yeah.
So, is it just var that we can do? Can we, assign these to anything else?
Yeah, so lambdas and delegate types can be assigned. They have several base types. So object, for example, all lambdas are objects, so that works. You can say that all lambdas are delegates, just system.delegate, and that works just fine. And all lambdas, or most lambdas, can be converted to expression trees, and so the expression trees have a similar base type called expression, and that works as well. And then lambda expression, which is the more derived, all shared base type. Right. And so that's actually an expression that turns it into an expression of func of string of int and int, and then converts that to an expression.
Right. And before we would have had to ask the compiler, like, put all those types in, write all the generics to say this is actually what it is. Whereas now the compiler can just figure it out, right? It says, oh, you want this as a lambda or a delegate or an expression tree just by the type we're assigning. And so we can do all that conversion for you, because rather than having to just like be explicit about it. Yeah, so that's cool. But what about this one, right? Where we talked a little about how without the string information, it would fail. So if we tried to make this a var, make this a var, it's not going to work, right? Because, well, we're returning an int and we're returning a string. And so, like, what is the return type of this thing? Like, we said it was an object before, but, like, we can't, like, just infer that it's an object, right? Because it could be I-formattable. It could be a whole bunch of things, right?
Yeah. So, it could be I-comparable.
Yeah.
So, we added the ability to specify a return type. So you don't have to go back to func and re-specify types in multiple places. You can just write what looks like a method signature, right? So you have your return type on the left, and then you have a space where if lambdas could be named, that's where a name would go. And then you have the parameter list. And so this is just a method signature minus a name.
Right, and this kind of looks a lot like a local function or even a regular method, right? We've got the type and the things. And so, again, it just goes back to our idea of kind of unifying all these concepts, that they're all different kinds of methods, and now you can represent them in the same way, right? So the syntax kind of maps the same, whether it's, an anonymous function, a local function, or a full method body. It's all kind of the same shape, right?
Yeah.
Cool, and we have other things as well, other than just delegates and methods and local functions, right? We have method groups, and I believe we did some goodness for those.
Yeah, so, people often take functions of their method groups as well. And so now we can do the exact same thing that we do for lambdas. So if we can say, yeah, we know what the type of this thing on the left is, or sorry, on the right is, then we can just infer the type on the left. There's only one console.read. So that's very easy to figure out. Obviously, it's the one that exists. Something like console.write, on the other hand, there are 17 overloads of
Yeah.
right. Did you mean the one that takes a bool, or the one that takes an int, or the one that takes a string, or there are a lot of different overloads.
And
So
again, we're not going to be in the business of guessing which one you want, right? Like
Yep.
we're just saying, no. You need to specify exactly what thing it is you want here.
Exactly.
So you have to keep that. Okay, that's pretty nice. So we still got a little time for demos, right? So
Yeah, still a bit.
interpolated string handlers, huh? This is a little dear to your heart. How long have you been working on this for?
About a year. Yeah, about a year.
just a short amount of time then.
Yeah. So C#6 added interpolated strings, which is string builder, the string builder.append right here. Which, if any of you are familiar with interpolated strings, you have alarm bells going off in your head right now, because your interpolated strings are basically just syntax sugar for a call to string dot format, right? So that's actually what it's calling. And so we're creating a string, and then we're like throwing the result, and then we're adding it to a string builder. And then the whole point of a string builder is that we're not creating intermediate strings. And so we've just totally invalidated the purpose of the string.
So there's this hidden string creation here, right?
Exactly. And it's like, that's unfortunate. There's also, like, if you've ever used a logging framework, almost certainly you've run into guidance that says, no, don't use interpolated strings in my logging framework. What if the log level, what if the error level is set to error, and I'm logging something at debug? Why are you doing any of the work to make the string? No one's ever going to see it. If a tree falls in the forest, doesn't make a sound. Well, yes, if you're using an interpolated string hit. So we wanted to try and address these problems with interpolated strings and make them more efficient in general.
Right, and I think just to point out, I think a lot of people don't necessarily realize as well that here, because it's lowering to string format, this is actually happening in the runtime, right? We take this and we parse it, and then we turn it into this format string that you could have also written, and then the runtime has to go at runtime and go, go parse out this bracket and go execute this and put it back here. So we're kind of doing a lot of duplicate work as well, right? Like it's under the hood. Like we figured all this stuff out and then throw it away and then refigure it out at runtime.
Yeah, and these are all problems. So what we did in C#10 was we added a new type of handler for interpolated strings called interpolated string handlers. And so if we look at that string builder call, we'll see that it's actually not calling a string overload. It's calling this string builder.append interpolated string handler overload. And so what this handler is basically it is a much more complicated lowering. So it's going to create one of these handlers, and it's going to pass in the string builder to that handler. And then it's going to call handler.append literal for the hello part, and then it's going to call append formatted with the args, and then it's going to call append literal again with that last bit. And that handler, because it was past the original string builder in the constructor, it can just directly append all of these components to the string builder. There's no runtime parsing of this thing. There's none of that. It's just directly going into the string builder. That's it. Yeah.
So that's pretty neat. So we've no longer got this hidden string allocation here, and we're no longer doing this at runtime, right? It's happening. Well, obviously it's happening at runtime. We're no longer doing the parsing at runtime, right? It just goes in and it just becomes a series of function calls that just goes this one, this one, this one, this one, rather than actually having to go in and dig out these brackets and figure out what to do, right?
Yeah, and we can use these handlers for a bunch of different scenarios. Like, for example, logging or debug.assert. Debug.assert says, if there's some condition that failed, create this, display the string. But debug.assert doesn't actually need the string if the condition is false. But that's not how things worked in C# up until this point. So we added the ability for interpolated string handlers to have an out bool parameter for the constructor. And if should append gets set to false during the creation of this handler, well, we're not actually going to call any of those append literal or append formatted. So, and we're not going to run anything in those format holes. So that formatting of datetime.now, that whatever expensive calculation that is, we don't need to do that. You don't need to worry anymore about, oh, because this thing is going to do something complicated, I need to put this debug.assert in an if, and then I probably need to wrap that whole thing in pound debugs. None of that anymore. And loggers can use this as well and say, oh, we're not logging at this level. Don't do any of the work.
Right. And so where before we had to go create the string and we'd always evaluate these things, do all the hard work, and then pass it in only for the debugger set to say, no, the condition's, false, the condition's true, so just throw all this work away. Now we know up front whether or not we actually have to go and evaluate these, right? So that's what's kind of nice. We defer doing it until we know we have to. And so that's true with, like you said, with loggers. If we're not actually logging, we'll just ignore it and we won't do any of that work.
Yeah, and then another problem interpolated strings have had is how do you create one with a different culture?
Right.
Like, for example, invariant culture. Previously, we've used formatable string to allow you to do this, but that's expensive. It adds a bunch of extra allocations. It saves things off on the heap that don't need to be saved on the heap. It's not very simple. And so with handlers, we can now say, all right, create with a handler, and then it will get that invariant culture in the handler constructor and do the construction of the string in as it's happening, and without having to introduce new types and new allocations there.
Nice. And as a user, is there anything I need to do to take advantage of all this good stuff?
Absolutely. Well, I mean, for the invariant string, you'll need to call the new method, but otherwise, absolutely not. The goal of interpolated strings is you recompile your program and it gets faster.
Right. So we've threaded all these string handler instance things through the BCL and through the libraries, so that now all you do if you recompile, rather than using the string format, we're going to go use these fancy string handler things. So it's pretty complicated in the back end, but as a user, it's just goodness, right?
Yep. And if you're a library author, you can introduce one of these. Of course, you can make your own, and then your users just have to update to the new version of the library and recompile. And
right. So if I have
sins that they've been committing, they just go away.
And so if I have some JSON serializer or something, I can create some JSON interpolated string handler, and now it will just do the right thing, and me as a user, I don't have to worry, right? It just says, no, we're going to be intelligent, and we'll go do that.
Yeah, and actually in Roslyn, we have a PR out that's hopefully going to be merged either today or tomorrow that's going to switch our contract handlers over to these, right? So we have like contract.throw if null or contract. Throw if false or what have you. And we found that in certain extreme scenarios, when you hit control dot, that can actually consume like 250 megs of allocations to those strings. And so with these handlers, there will be no more allocations. It just won't happen unless we're going to throw anyway.
Magic. All magic. It's wonderful. All right. I think that is a pretty good rundown of some of our C# 10. Should we go see back to the slides what we're going to be thinking about doing next?
Yeah, I mean, we're not done. By no means is C# done evolving and done going into the future. So,
apparently there's a hidden.
all right. So in C# 10, we're out now. We have a preview of generic math, and you can find a blog post from Tanner Gooding on the .NET blog from, I think, mid-August or so, that talks about the shape of generic math and what we're planning on it. So this is basically being able to say static abstract in interfaces, right? And that allows you to have a zero operator and a plus. And so then int32 is going to implement that operator, and then you can write generics over that. So can you go to the next slide? Yeah, and so you can add all method that works over anything that is additive identity, i.e. that has a 0 and a plus operator. And so that allows you to say, all right, for this array, sum all the results and return the results, and it's exactly as efficient as if you had written that for loop by hand for every single numeric type in existence, which is, a lot of work. And this is a lot less work. And so this is a big feature. We didn't think that we could get it right if we attempted to ship it without extensive public testing and preview, and seeing what worked and what didn't. And so it is in preview right now. If you go set your Lang version to preview and turn on the experimental runtime features, you can use it. Again, Tanner's blog post has all the details on how to actually try it out. We've already decided we're going to make some changes. Like, for example, in the previous slide, there was a where t this, which is something we're thinking about, because right now you have to specify I-additive identity of t, where t is I-additive identity of t, and where t this is much clearer and prevents you doing something odd like implementing I-additive identity of int on some other type, right? That's not this. So we're still looking at changes there, but absolutely, please go try it out and give us your feedback.
Okay, and then we have one thing. This is something else which is actually in preview. It almost made C# 10, and for edge reasons we didn't, but it will be in C# 11. We now allow you to use generic attributes. So before, an attribute couldn't have a type parameter, and you could kind of get around it by putting like a type of thing, but the arguments you can pass to an attribute are very limited because of the way they're encoded in IL. And so this is actually a change in the runtime to allow you to have a generic argument on an attribute. And really, we're surfacing it. So it's really a big runtime change with a very small language one, where we now just allow you to have that, bracket t. But it means you can create like a my attribute of int or my attribute of string. And so you can now actually pass types through that way to make those attributes generic. And you can get these things at runtime as you'd expect. They're actually part of the runtime itself. So yeah, in preview now, but should be pretty solid in C# 11, which is great. If you were in our talk last year, you probably remember this slide. We again, something we were thinking about doing in 10, but we're now going to do, hopefully do in C# 11. And this is something we call semi-auto properties. And really what this is inside a property, you have this field keyword. And so today we have auto properties where, you can just say get and set. But then if you want to actually, and we'll go and generate that backing field for you. But if you want to reference that backing field, then you're kind of out of luck, right? You have to go and create that backing field yourself and then go create the getter and the setter. And so it's kind of like, auto properties are great until you need a little bit less automatic, and then you're kind of on your own and you have to go back to the very old style properties. And this is obviously true for things like, if you've ever done MVVM, then like INotify property change is sort of the obvious one that, everyone wants to do this in. And so we're basically going to allow you to use this field keyword inside an auto property to say, yeah, we know the compiler is going to go create this field for us anyway. We don't know what it's going to be called, but within here, we can just reference it. And so we can just say, actually, this is the name of the backing property the compiler is going to go make. And so you can actually reference it and set it. So you no longer fall off that cliff of like, I just need to, just use the backing property slightly. You can now do that. And so that's with the field keyword. So there's obviously a lot of use cases, especially around UI stuff, where I think this will make it really very, very nice.
Yeah, and so another slide you might recognize from last year that we didn't quite get to in C# 10 is required properties. And this is something that's next on my plate to go implement, and I've been working on this for quite some time. So I would really like to get this into 11. But the idea is that, if you have a POCO or you have some type of DTO or, some class where having a constructor is not a good thing, you can't say that every instance of person that I get is going to have a first name or a last name. But if you have nullable turned on, the compiler is going to warn you and say, no, these things don't have default values, and yet you said that they're strings and not nullable strings. What are you doing? And you can't tell the consumer of this type. You need to be the one that implements, that sets this on construction. And so required properties and required members, really, because you can use this for fields as well, is how you actually do this, and how you say, all right, we can actually take this property and we can say, when you call new on this thing, you must, and you will get an error if you don't, set a value for those fields. And then we're also looking at it's another version of C#, and so that means we need to have another turn of the crank, as we call it, on patterns. Another new feature for the whole pattern space as we mature it out. And in this case, we're looking at list patterns. And so if you're familiar at all with functional programming, this was one of the simpler examples I could come up with. And so you can do cons list, for example, which is it's a linked list. And so this would be how you would write a map with a list pattern. This is how you would write it in most functional languages, F#, for example. But now you can actually, or you will be able to write it in C# like this as well. We're hoping to get this out into preview, I think, for 17.1. And so give it a try. Give us your feedback. And in this pattern, we have two patterns here. We have the first element, and we have the rest of the elements, and then we have the base case of the empty list. And so that just maps you a new cons list.
Nice. And so another feature which we're actively working on right now is something we call raw string literals. And so in C# we've always had what we call verbatim literals, right? You put a little at in, and then ideally you can just type anything you want in there, right? But that falls down when you want to use quotes, because you have to double quote them, right? Because to say, well, this is actually the quote. And then if you want to put double quotes in, you have to quadruple quote them, because you have to say double quote and double quote. And it gets really confusing really fast. And then if you want to combine interpolated strings with a verbatim, then again, as soon as you want to try and put curly braces in, then that gets really hard and you have to put two curly braces in. And so essentially, if you want to paste a bunch of JSON into a string in C#, right now it's just kind of a mess, right? Because it's full of quotes and it's full of curly braces. And so as soon as you want a verbatim, an interpolated JSON string, it's just very complicated. And so what we're looking at is making these what we call raw string literals, which is like a kind of new kind of string. And these start with at least 3 quotes. And what that says is these 3 quotes are actually going to be the quote character that ends the string. And so anywhere in the string, you can write a single quote and we won't terminate the string until we see on an empty line those 3 quotes at the end. And actually, if for some reason you needed 3 quotes in your text, you can make those 3 quotes 4 quotes or 5 quotes or 6 quotes, and we'll look for that matching end delimiter to say that anything less than that is part of that raw string. And you can do the same with the interpolations as well. So we'll actually say that, oh, here we have $2. And so that says the interpolation character is 2 braces. So these things here of the JSON are not an interpolation hole. This is just a regular character. But down here we say, oh, now we've got 2. This now is our interpolation hole. So rather than making you, essentially it flips it around. So rather than making you escape the regular characters, you effectively go in and redefine the special characters. And again, you can add as many dollars as you want to make as many braces if for some reason you have 2 braces in your string. And one of the really neat things about this, if you ever pasted these blocks in, is obviously the code starts over by this var. And so there's all this white space before, but really we want it to start at the $, right at this quote point. And we don't want any of this white space off to the left. And so raw string literals actually do that now. So when you put these bottom quotes in, we basically take everything before the quote and remove it. So you effectively just get the everything on the right of where it started. So you get proper indentation in your strings. So we think this will be nice.
The IDE is going to include some guide helpers when you do this to show you where the indentation is going to be trimmed off.
Right, exactly. And you can move it around and it will show you exactly what you're actually going to be consuming. But we personally as compiler developers are very excited about this. We have a lot of C# code in our tests, as you can imagine. And it gets very, very complicated very fast because, you look at things on screen and you're like, well, what actually is that? And you have to kind of unescape it in your head to work out what it's actually going to be. And so with this, you don't. You can just put it in. What you see is what you get. So we're pretty excited about this. And I think a lot of people are going to really, really like this feature. All right, I think that is everything. As always, we like to say, Roslyn and C# are open source, so please do get involved. If you want to get involved in the language design, then go to .NET C# Lang, and you'll see Fred is pretty active on there. That's where we do all the design. All the meeting notes are published once a week from the language design meetings about what we're thinking, what we're working. So you can always see everything we do is in the open, what we're working on. And if you want to, go comment, that's a great place to get comments earned on the language before we, while we're still thinking about them. And then we also have Roslyn, and Roslyn is the actual compiler thing, which is where I tend to spend most of my time. And that's where we actually implement the language, right? That's where we actually go and we take these nice features and turn them into a compiler. And again, open source, we have a bunch of contributors who help. If you want to come get involved, we're friendly, we'll help. And you can always come talk on Twitter, Anchors99. A lot of the developer team is on there as well, so you'll see us be pretty active. And then also in Discord, Fred, we've got a pretty active community there as well now, right?
Yeah, last year I was about the only member of Roslyn that actively participated in the Discord, but now we have a good 4 or 5 members of the team on there. So
nice. So yeah, come talk to us. Come let us know your thoughts, and come help out if that interests you. So thank you very much.
Chris and Fred, thank you so much as well. Very dynamic, very insightful, very practical and hands-on as usual. So congrats. Very, very good one. Good. We've got a couple of questions, of course.
Yeah, absolutely.
Would you like to go first?
Yep. I was wondering, since I've witnessed some discussions around this and some users who are having issues with this, what is your take on implicit usings? Because I understood that sometimes there is the need of adding the package explicitly, even though you have implicit usings enabled.
Yeah, ultimately, like you still have to add some. If you're adding new things, we're not going to go and pull out like NuGet packages and things. Really, it's just like the sort of small subset of things that we know you're always going to use. And so the idea is then, when you look at your file, you'll say, oh, I'm actually using this package in this file or whatever, versus it getting lost in the sea of system and all the other, collections and threading and things. So really, you can think of the implicit usings as just being the baseline of just like, these are the things that you don't need to think about and aren't really interesting. They're just language features and things in the runtime. And then you have your explicit usings, which is like, this is, Newtonsoft, or this is whichever package it is you might be using to say, I'm using features from this NuGet package here, rather than something that's built into the language and the runtime itself.
Thank you. And I think one final remark from me. So I'm usually, or from time to time, reading the TIOBE or TIOBE index, languages index. Not sure if it's something that you're aware of. And right now I'm seeing here the December headline: will C# become the programming language of 2021?
Let's hope so.
Let's hope so. I'm also looking forward to understand better how they do this ranking and everything. But of course, I'm gonna wish good luck C#, and because we all see the work that is behind the language. You guys are brilliant, doing a great stuff. And of course, we're looking forward to have you back at Codecamp anytime soon.
I'm sure we'll be back with C# 11.
Yeah, I did see one question in the comments as well that I will call out and answer.
Okay.
So Adrian asked about the lambdas. If we have an inferred lambda with a big anonymous function in the middle with multiple returns, is the compiler smart enough to infer that? And the answer is yes, with an asterisk. The compiler is smart enough to infer things. It's just that if you make the compiler do a lot of work, it might slow down. So if you have multiple nested lambdas with a bunch of returns, that's an n² operation to try and figure that out. And so you can cut out the combinatorial explosion by putting a type in somewhere.
Thank you so much. Then, Chris, Fred, always a pleasure to have you at Codecamp, and see you next time.